We are used to artificial intelligence living safely inside our phones. Recently, the Unitree H1 robot hit an outdoor track and clocked a sprinting speed of 10 meters per second. That is 36 kilometers an hour. This physical manifestation carries violent consequences. On April 10th, an attacker threw a Molotov cocktail at the San Francisco home of OpenAI CEO Sam Altman. The battle over who controls artificial intelligence has spilled out of server farms and into the streets. For decades, we treated algorithms like a brain in a jar. They could translate languages or write code, but they were trapped behind glass. When you closed your laptop, the system ceased to exist in your environment. As of April 2026, that glass is gone. The global tech race has shifted away from chatbots towards physical AI. Engineers are rapidly closing the sim-to-real gap, the technical hurdle where code that operates perfectly in a digital simulation fails in the unpredictable real world. Giving code a physical body transforms the business model. Companies are moving toward the deployment of autonomous hardware, a shift that creates an immediate strain on existing infrastructure and safety protocols. Before we look at the bodies, we need to understand the brains. The software architecture has moved from generative AI, which passively answers questions, to agentic AI, systems that independently plan and execute tasks. Early models, like the OpenClaw framework, acted like static routers, shuttling commands to different apps. If a script broke, it stayed broken until a human programmer fixed it. New open-source frameworks, like Hermes Agent, monitor their own output. This process is called closed-loop learning. When an agent hits a dead end while coding or writing a report, it stops to analyze the failure. It writes a custom patch for itself, saves it as a new skill, and uses that upgraded logic on the next attempt. This evolving logic is being plugged into personal knowledge bases, like the GBrain system. Before the AI begins a task, it reads your specific context, your past emails, your calendar, and your ongoing projects. After the task finishes, it writes the new insights back into its memory. You are no longer talking to a blank slate every time you open a browser window. You are working alongside a compounding digital colleague that accumulates experience with every interaction. A compounding digital intelligence requires a capable vessel. Tools like the BrainCo Revo 3 robotic hand feature 21 degrees of freedom and tactile sensors across the entire palm, allowing these digital brains to interact with physical objects. The major engineering hurdle here is rigidity. Older robotic joints would snap if they hit a solid object. The new mechanical standard is backdrivability. If you push against the robot, the motor yields to the pressure, allowing it to feel resistance and absorb the force. Tactile compliance allows code trained millions of times in a virtual space to map directly onto physical hardware without the robot destroying itself. By feeding direct physical sensor data into these optimized models, these machines achieve a reasoning speed of under 100 milliseconds. They process tactile feedback and execute complex mechanical operations faster than human reflexes. Hardware that yields to the touch and software that reacts in milliseconds allows robots to navigate real-world chaos. Physical agency has permanently escaped the laboratory. Powering these autonomous physical systems requires a scale of computing power that has outgrown Silicon Valley's traditional growth models. OpenAI recently scaled back its multi-billion-dollar Stargate project, losing 3 key executives in the process. They hit a physical wall. The United States grid faces a 92-gigawatt electricity shortage, and brute force scaling has met the limits of the power grid. In Europe, the strategy looks different. Mistral AI is deploying localized data centers in Paris and Sweden, aiming to control hundreds of megawatts of autonomous compute independent of American tech giants. Funding models are also shifting. Mistral secured over $830 million through traditional bank debt. Global financial institutions are now treating server racks full of specialized chips as collateral. Major banks now treat high-performance server racks as stable collateral, valuing them like toll roads or sovereign power plants. As this technology gains both physical autonomy and immense financial weight, it creates what Sam Altman describes as a ring of power effect. The realization that general artificial intelligence could direct our infrastructure has escalated corporate competition into public fear and real-world conflict. The companies building these systems recognize that statistical math cannot solve moral questions. Anthropic recently hosted a closed-door summit at their headquarters, bringing in 15 Christian theologians and ethicists to advise on how their models should navigate morality. They embedded a massive, hard-coded constitution into the model's architecture. This creates an intelligence that acts as a conscientious objector, a system designed to refuse human instructions if it determines the request violates an ethical baseline. While engineers debate theology, governments are dropping an iron curtain of regulation. The European Union has implemented a hard law AI Act, the United States is fragmented across contradictory state laws, and China has mandated domain-specific ideological barriers. The utopian idea of a single algorithm freely connecting the entire globe is gone. We are entering an era of fractured, highly guarded sovereign systems. The machines are gaining memory, touch, and speed. You cannot compete with them as a fast-typing task operator. Moving forward, the most valuable skill you can develop is learning to be an orchestrator, someone who curates the context, guides the ethics, and manages fleets of these autonomous agents as they integrate into our physical reality.